Hi everyone, thanks for joining in. Today we'll talk about the very interesting space of building conversational interfaces for our applications using language understanding, automated speech recognition, text-to-speech capabilities, and look at analyzing users' interactions using language processing. My name is Atanu Roy and I work as a solutions architect focused on artificial intelligence. It's no secret that a large number of companies are trying to reimagine how to improve their application users' experience and building a conversational interface so that the users can interact with their application through voice or text commands. What's encouraging them to take up such project is the availability of different cloud-based tools which let them solve very difficult problems very easily. For example, NASA reimagined how it wants to reach out to students in schools and community organizations and inspire the next generation of explorers. They created a conversational interface for their robotic ambassador Rovi, which is a close replica of the NASA Mars rovers, by the way, so that students can ask questions about Mars and get interesting answers. It's the same intention of making user interactions more conversational that led Capital One to make all their customer-facing online transactions voice-driven, where you can check your balance, pay your bills, track your spending through voice commands, or allowed Liberty Mutual to add chatbot capability to their existing web application. Now, if you have to build such systems from scratch, let's look at what are the challenges you have to solve. You have to build an accurate speech recognition engine that will convert the voice commands to text. You'll then have to build a natural language understanding engine that will accurately extract the user's intent from that text. Once you have a response ready for the user, then you have to convert that text to speech and play it back to the user all in real time. These three by themselves are extremely hard problems to solve. But imagine, even if you crack them, you need to take care of how to build dialog flows, how to easily integrate with your application or a messenger service, how to scale to thousands of concurrent users, how to achieve high availability of each component. Think about it. It's really a significant amount of work. Now let's look at some of the tools that AWS provides to take away some of those pains. Amazon Lex is the primary AWS service which lets you build conversational interfaces using voice and text. It uses another AWS service called Amazon Polly to convert text to speech whenever you want to interact with your user through voice. By the way, customers use Polly independently to implement a wide range of use cases too, like generating audiobooks, news on the go, IVR systems, etc. And you can use a third AWS service called Amazon Comprehend along with Lex to analyze the user's conversation to understand what's their overall sentiment of the interaction. Going forward, we'll refer to these services as Lex, Polly, and Comprehend. So combining these three, you get a complete end-to-end solution managed and hosted by AWS that will provide, among others, native support for text-to-speech, speech recognition and language understanding integrated into one single API, one-click deployment, and fully managed scalability, easy business logic integration, fully encrypted data at rest and in transit. Some important features to know about Lex. Firstly, the NLU and the speech recognition capabilities are powered by the same engines as Amazon Alexa, but exposed as a single API which can take both text and speech. Another cool thing about LexBots is that you build it once and have the choice of deploying it multiple times to either your mobile app through the iOS and the Android SDKs, or to messenger services like Facebook, Slack, or Kik, or integrate with your web application using one of the many supported SDKs like Java, JavaScript, Python, .NET, Ruby on Rails, etc. Or even deploy it on your IoT devices. As we'll see during the demo, it has an efficient and intuitive console which allows builders to design their bots easily. Lex allows seamless connectivity with multiple enterprise systems like Salesforce, Microsoft Dynamics, Zendesk, etc. Importantly, it provides out-of-the-box capabilities to monitor interactions through CloudWatch logs, analyze missed utterances, and add them back to the intent from the console. Now we will look at depth into how to build conversational apps using Lex and what customizations can we build into our bot. Later, we will demo how to create a bot and integrate it with your application. We start by defining the actions to be performed by the bot. These actions are defined in Lex as intents. For each intent, we will add utterances and slots. Utterances are a list of sample phrases that the bot users are likely to use to invoke that intent. We use these utterances to train our language model. Slots are like variables populated by user inputs that will capture useful information to fulfill the intent. Lastly, we will provide the business logic necessary to execute the action by defining a fulfillment. As we will see later, Lex lets you use AWS Lambda to make this incredibly simple. Now let us take a closer look at how utterances and slots work. Let us imagine we are going to create a travel bot, and we will start by defining intents like book hotel, book flight, book car, etc. Now for each intent, we will provide a few sample utterances that could potentially be used by the users of the bot. For a book hotel intent, it could be utterances like I want to book a hotel, can you book a hotel for me, please reserve a room for me, like these. Lex will trigger this intent when the user speaks or types something along those lines. Please note that this is not exact match by any way. Just a few samples will let Lex know what you want. Next, we specify slots. These are additional information that you request from the user before you are able to fulfill the intent. So for our book hotel intent, we will instruct Lex how to elicit slots by prompting questions about the destination and the number of nights. And Lex will populate the user's response to the respective predefined slot variables. Lex allows you to define what kind of data type you are looking for in those slots. It provides a list of native data types and additionally lets you define your own data types. Lex will automatically extract a slot from the user's response. For example, if user says I want to stay at New York City, Lex will extract New York City and populate the slot. Lex maintains a conversational context throughout the life cycle of the conversation. It stores information that a user or the application provide to fulfill an intent. Conversation context includes slot data that the user provides, the intent that is currently being fulfilled, and request and session attributes that the client application can create. Lex lets us invoke a AWS function at every turn of the conversation. AWS Lambda, for those who are not aware, lets you upload a function in any of the supported languages like Python, Java, Node.js, etc. and set it up to trigger directly from other AWS services, or you can call it directly from any web or mobile application without the need of setting up or managing any infrastructure. We will see in the next slides that we can use AWS Lambda as a code hook to customize Lex bots in many different ways. First, let us look at switching from one intent to another. For example, if the user is currently progressing through book hotel intent and based on the interaction looks like Airbnb would be a more appropriate option for her, then we can ask whether she would want to book an Airbnb instead. And if the user responds yes, then we can switch the conversation to a different intent called book Airbnb. This also gives us the ability to chain intents like book a car after a hotel booking, for instance. When Lex calls Lambda hook, it sends all the required information as a JSON payload like the one we can see on the screen. It contains the name of the bot, intent, slot values, and also any session attribute if required. You can see now how Lambda will send the response back to Lex after processing the user's interaction and determining that it might be useful to switch the intent to book Airbnb. It will create a dialog action with type confirm intent, set the message to be prompted to the user, in this case would you like Airbnb instead? And finally, define the destination intent to switch to, which is book Airbnb. You will soon see that we can play with the different values of dialog action type to control conversational flows very effectively. Dialog management in Lex is very easy to set up in the console and lets you build multi-turn conversations using simple declarative model. However, if you want to create dynamic conversations and use customized prompts depending on the situation, we can do that too using similar AWS Lambda code hook that we discussed earlier. For example, if our application captures users' past preferences, then when the user comes back to our chatbot, we can prompt a customized message like, would you prefer to stay in downtown this time as well? This gives a more personalized feel to the user. In order to achieve this, the Lambda hook will have to send a response back to Lex similar to the one we saw earlier, but setting type as elicit slot in the dialog action object along with other details. If you want to analyze the sentiment of the user and take necessary action based on that, we can do that with a single API call to Amazon Comprehend from the AWS Lambda code hook. For example, we could prompt the user for a feedback and the user could respond, sorry, this did not help. We can use Comprehend to identify the negative sentiment in the user's response and offer to transfer her to a human associate. We will see more about this when we build the demo. Lex also supports elegant error handling flows natively. For example, if the user's response is not legible or a slot cannot be extracted from the response, we can ask them to retry. We can use a different prompt each time and finally hang up with an appropriate prompt once the max number of retry is over. Finally, once we have mapped the user inputs to an intent and all the required slots are defined, we need to create the output for Lex. We can create simple responses or pass the intent and slots to AWS Lambda to implement complicated business logics. AWS Lambda will integrate with AWS or other services as required. For example, if the user is ordering pizza, then we might need to integrate with your stores API. In our example, when the user books a hotel room, we might need to update the database with the booking details or contact our ERP system. At the end, Lambda returns a response to Lex, which then forms a response back to the user. As we keep iterating through the bot design, it's important to know that Lex allows us to version all the changes we are making to the bot, which also allows us to roll back to an older version if the latest version is not working out well. Before we publish, we can specify an alias and map the alias to a version. This is useful to create development, test, staging or a production version, for example. When we save an intent change within a bot, we need to first build this new version. This will create the underlying NLU model based on the slots and utterances that we have defined while designing the bot. We can then test the bot and if satisfied, publish it to the live environment. While there are many ways to deploy Lex bots to multiple channels including Facebook Messenger, Slack, etc., and then there are many tutorials already available that tells you how to do that. Today we will demo how to integrate Lex with your web or mobile application. As you can see on screen, for this demo we will use a serverless architecture where we will call the necessary AWS APIs directly from the browser using JavaScript. It does the authentication and authorization using AWS Cognito, which generates a temporary token so that you do not have to store any credential on the client. After that, it calls Lex and Poly directly to integrate with your chatbot. Since JavaScript is the basis of this integration, we have hosted the application directly out of Amazon S3 as a static website. By the way, the full code is available in the GitHub link that you are seeing on screen, and it comes with a very neat CloudFormation template that creates the entire stack with a single click. The bot we are going to build today is one that many of us have wished for many times. It's an excuse bot. The base version first created by some of my colleagues in India for a workshop, which I modified to add a bunch of new features to it. you can ask it to generate an appropriate excuse for one of your common sins. It takes in a few inputs on what did you do to need an excuse for, or when you did what you did, and generates an excuse. Some of them are interesting, others quite hilarious. Alright guys, we are going to start with the Amazon Lex console. We will go to the AWS console and hit the Amazon Lex. Once we are at the Amazon Lex console, we are going to first create a bot, and since we are creating a bot to generate excuse for, let us name it excuse bot. Next, we are going to choose a voice. These are some of the voices that Amazon Polly supports, as in when you input a text to Polly and generate the speech out of it, you can choose which of the supported voices you want to generate speech to be in. In our case, we will use Sally as the voice, which means if Lex calls Polly to play a voice back to the user, it will use Sally as that voice. We are going to put the session time out as 5 minutes, and then we are going to click on this radio button, which tells that this bot is not subject to Children's Privacy Protection Act. So we hit the create button, and now our bot skeleton is created. Now, as discussed earlier, whenever you create a bot, the first step is to define the action for it, and the action for this bot, by the way, is to generate excuses. And how do you define an action? You define by creating an intent. So we will go and create an intent, and we will name this intent as excuse intent and add it. You can see that the excuse intent has been listed here. Once you create an intent, next we have to add some sample utterances. If you remember, purpose of utterances is to let Lex know how the end user is going to invoke this intent. What are the different utterances the end user could potentially use? In this case, it could be, can you generate an excuse for me? That is a valid question to ask. It can also ask, give me an excuse. You can go ahead and ask, need an excuse, if you are desperate enough. Let us for now just define these 3 utterances. Thing to remember is that by no means these are exact matches. So it is not that the user has to come and say exactly these same sentences. These are just some samples that we use to build our language model, and as long as the user comes and says something around these lines, it should be picked up. Once you create the utterances, the next step is to create the slots, and for this bot we are going to collect 2 information from the user. One is, what is this excuse needed for? I mean, what is the reason for the excuse? And the second one is, when did she do whatever she did to need the excuse for? So the first one, we are going to name it excuse for, which means what is the reason for the excuse. Now, if you look into the slot type, you can see that it comes with a bunch of implicit data types that Amazon provides. For example, there is one date, there are others for color, for country, for city, etc. But for the excuse for slot, we are going to create a custom slot type, because there are some specific inputs that we want to gather from the user. So let us go ahead and create a custom slot type, and we will name this as excuse type. Okay. And we need to give the different options that this slot is going to capture from the user's response. So for this demo's purpose, we are going to have 3 types of excuses addressed. One would be forgot birthday, very common, at least for me. Second could be forgot anniversary, you better not, but just in case. Third one could be missing office. Do not know whether that is applicable to you. Okay, so these are the three different reasons for which this bot is going to generate excuses, and those are three values we defined for the slot type variable. Now, once we are done, we can directly add the slot type to the intent. We click on this button, add type to intent, and once we do that, you can see that one slot has already been created with the slot type as excuse type. We are going to name this excuse for, and we need to prompt something to the user, the response of which is going to come and land into the excuse for slot. So, let us prompt, what do you need the excuse for? That is a valid question to ask. So, that is our first slot. As I mentioned, the second slot is going to be the date for when she did what she did. So, we are going to name this excuse when, and since this is a date type, we will go ahead and use the Amazon implicit date data type that is available. We need not create a custom slot type for this one. And let us see what we can prompt. We have captured the reason for the excuse and we need the date. So, let us ask, okay, when did you screw up? Okay. And we are going to add this, choose this for the intent. So, now we have our slots ready. We have two slots which are ready and we have defined the utterances too. So, next we have to define the fulfillment. If you remember what is a fulfillment, it is the business logic which will define the action to be taken by this bot, and we are going to using the slots and the utterances, and we are going to use AWS Lambda to build that business logic. I have already created a Lambda function known as excuse generator. If you click on the view in Lambda console, that particular link, it takes you to the Lambda console. You can see the excuse generator console, and it is a Python code, uses the Python 3.6 runtime. If you look at the code, the entry point to any Lambda function, the function that the trigger calls is Lambda underscore handler. It passes the event and context, capturing all the information that needs to pass, and from within the Lambda underscore handler, if the invocation source is fulfillment code hook, we call fulfill excuses, the helper function. Okay. Before we go to fulfill excuses, let us look at what we are doing here. So, we have these three reasons, excuses for missing office, and we have generated a bunch of different excuses for each of them. For forgetting birthday, forgetting anniversary, for each of these three types we have a bunch of different excuses that we have defined, and then we use the random library. We imported the random library and we will randomly pick up one of the excuses and show it back to the user. So, out of these different options, we are going to choose one of them. Within the fulfill excuses function, we are going to construct a message. The message would say, you should say, and then pick up the excuse, and also we ask like, so did the excuse help? Would you like to give us a feedback? So, that is our message, and to play it back to Lex, we are going to create a dialog action with type confirm intent, put the message there. Okay. So, confirm intent has to be the type, whatever message we constructed, we are going to pass it in message, and then we are going to keep the intent name as excuse intent, because it is going to go back to the same intent, and we pass the slot values that we have. So, that is our Lambda. So, now we have the fulfillment Lambda ready. The only thing we are left to do is do the sentiment analysis of the user's interaction, and we do it by defining a validation Lambda code hook. So, in the validation Lambda code hook, we are going to capture the user's interaction. We are going to use Amazon comprehend and to capture the sentiment, and based on that we are going to take some action. So, we click on to create this Lambda hook. Again, I have a pre-created lambda function which is known as sentiment extract sentiment, and again you can click on this link that will take you to the lambda console to the extract sentiment lambda function. Here also I have used the Python 3.6 runtime, and in the code you can see that we are doing some interesting things. So, firstly we import Boto3 library which is the AWS Python client, and we create the Amazon comprehend client by just calling Boto3.client and pass comprehend as a parameter. So, that gives us the comprehend client, and then we call the detect underscore sentiment function on the comprehend client and pass the text, the input transcript that the user has passed in, give the language code as English, and we get the sentiment back. That is where we are getting the sentiment. And if the sentiment is negative, what we do is we again create a dialog action with the type as delegate, because what we are going to do here is if the sentiment is negative, we are going to pass the flow back to Lex along with the slot values, so that it can generate one more excuse and give it back to the user to see whether she likes it or not. If the sentiment is positive, then we are done. So, we put the type as confirm intent, and with a satisfied message, okay, because there is nothing more to do. The satisfied message is thanks for your feedback, glad to be of help, and then we switch the intent to a successful operations intent. So, that is it. So, we have the sentiment analysis hook 2, we have the slots, we have collected both the two values that we want, we have the fulfillment lambda, we have the validation lambda. So, we are done, we are ready to build. Before doing that, we will quickly save the intent, and there is one thing I need to do before hitting the build button is we will create a dummy intent where the flow is going to pass once the user is satisfied and everything is done. So, this is where I am going to finally pass the flow back. Let me just quickly create this dummy intent, it does not do much, its name is new intent. So, I will quickly create that. All right then. So, we are ready to build our bot. So, we will hit the build button and it takes close to a minute to build. So, while it gets built, you can see that there is a test chatbot link on the right which you can click. This gives a very cool little way of testing out your bot, the features. There is a place where you can type in your whatever you want the user is going to input, and you are going to get the response from Lex in that, and it also gives you a way of inspecting the response. So, whatever are the details of the response JSON and the slot values, what is going to be the so it is going to give all that. So, now our excuse bot is built. So, let's test it out. We will write give me an excuse, okay, and okay, we get what do you need the excuse for. So, we are getting the response from Lex, and you can see that in the inspect response you have excuse for highlighted in blue, which says that that is what the response to this prompt is going to be filled with. So, that is the slot which is going to be filled by this this particular prompt. Okay. Hit a build, just one more build. Okay. So, we will now go to the UI from which we are going to integrate the bot. We said that we are going to integrate this bot with a web application, and if you recollect the architecture, it is a serverless architecture that we are building, and we are hosting it out of S3 bucket only. So, all the required codes, the JavaScripts, which is primarily how we are going to integrate with Lex, everything is in this S3 bucket, and it has a few HTMLs as a hook point for those JavaScripts. If you go to the properties tab, you can see that we have enabled static website hosting, and you get a link. So, if you go to this link, that will actually take you to the web UI. This is the web UI, and it comes with iframe, generate excuses iframe. and this is where the user can click. So, this is how you integrate with your application. So, let us go. We'll okay, the build is done. So, we are ready to test. So, let us type in need an excuse. Okay, let us see what do you need the excuse for. Let us say forgot her birthday, and okay, when did you screw up? Yesterday. You should say I did not know even you had a birthday, you are divine, remember. That is funny, not going to work probably for me. So, I say sorry, that is not going to work. Okay. It gives me another one. I did not forget your birthday, look at the future, walking sticks, medications, boiled vegetables, annoying grandkids. I was just being polite. Are you kidding me? That is pathetic. Okay, so it tries another one, that divine thing. Let us take it this time. Okay. So, that's I can try that out. That should work. Thank you. Okay. Once you hit that, it gives the positive response and it responds back, thanks for your feedback, glad to be of help. So, you could see that it captured the sentiment from my response. Whenever the sentiment was negative, it was trying something else, it was trying to give another excuse, and finally, when it detected a positive sentiment, it showed the satisfactory message and it takes it out of that intent flow. Okay. So, that is how easy it is to build the bot and integrate it with your application. To gain more confidence and hands-on experience with AWS, access the digital training built by AWS experts, attend our instructor-led classes by qualified AWS instructors, and learn how to design, deploy and operate highly available, cost-effective and secure applications on AWS, and validate your technical expertise with AWS and use practice exams to help you prepare for AWS certification. As mentioned earlier, AWS also has a wide range of partner ecosystem to help you focus on your success and take full advantage of all the business benefits that AWS has to offer. To learn more about APN partners and find the right one that fits your needs, please visit the AWS APN booth at our showcase. Finally, I would like to thank you for attending today and sticking it out until the very end of the presentation. Thank you.